last week, just to refresh before we go for the deep learning. Last week I mentioned we can use Gabor transform, which is short time Fourier transform, right? By select different scales and orientation, we can design a set of different filters. Okay, for the example like this, we use 4 scales and 8 orientation. Okay, and then we do the convolution of the input image with this filter. And each filter, for example, we take an image of a GIF, and then we do the convolution with each individual Gabor filter. And then we can extract the individual characteristic or features in the image, okay? And then we can, based on all the convolution result, and identify what the object in the image. Okay, that's how we do it, okay, to design the filter. But for the rest of the semester, then we will focus on the deep learning for computer vision. Then we started with convolutional neural network, okay? As I just mentioned here, all the filter based on the Gabor transform are given by some parameter, okay? The scale and orientation, and then we can set up the filter. But in deep learning, all the filters are designed or determined automatically, okay? Based on some of your objective and your application, okay? Then that will be our topic today. Okay. I need to go to. So all the material well in the direction, okay, DL, okay, deep learning for computer vision. Okay. You can find a lot of additional information from the directorate called DL supplementary. Okay, you can find that, but I don't have a time to talk about all the details. But even after the class, after the semester, if you are interested to learn more, you are encouraged to just read some more details information. Okay, but today we'll simply focus on CNN, okay? And then next week we will talk about autoencoder, then object detection and segmentation, and image generation, okay, and object detection. Okay, then we can finish all the topic on deep learning. And you're supposed to give me the outline today, right? Is that right? Okay, you can do it. Okay, you can do it during the break. Okay. But anyway, okay, let's focus on CNN. Okay. Okay, here's convolutional neural network. I believe some of you have learned this from different classes. Okay, so but let me just refresh in case you forget it or you have no experience at all. And at the end of the today's class, I will show some up-to-date or so-called state-of-the-art their model based on the convolutional neural network. Okay, so let's get started. Okay, I will quickly. So in case you cannot understand or you lost me, just raise your hand, let me know, and I can give you more clear. But otherwise, I will try to finish all the required information you need to know about convolutional neural network. Okay, and you will have assignment number 4 today. Okay, number 4. Okay, so most of you don't need to write your own. You just need to change a little bit about the CNN model and for the assignment so that you can learn something from it. Okay, and the sample will be related to your assignment number 3. Okay, it's wait for it down. Okay, wait for it down. Okay, let's start with the neural network. 30 or 40 years ago, whenever we talk about the artificial intelligence or we talk about the neural network, here is the basic model that you have learned. We have the input node, okay, and we have the input data for each node. So basically, the early day of the neural network is for the vector value data. 也就是你的输入呢都是向量资料 ，okay, just a vector. The so-called vector value data, they are well-structured data, such as the age, the salary, or blah, blah, blah. You need a feature. Okay, so in the early day when you apply this model for image processing, first you need to extract the features. What will be the feature? What will be the numerical representation in the image? That's something that we human beings need to do. Okay, to extract the features, and then we input it to the layer. And we try to find the weight that will connect between every 2 nodes in 2 layers and so on and so forth. Okay, that's the early day of the neural network. Okay, but this is the basic idea. We input the value, which is a vector, okay, a vector value. Element 1, 2, suppose we have up to n. Then we determine the weight. Okay, the weight are the decision variable that we need to determine. Once you determine the weight, then we sum them up, which is xi times wi, and then we sum them up. And after that, you will go through a so-called activation function. Okay, a 触发函数 activation function. Basically, as you know here, the connection or the weight from the input to the next layer, it does not have to be the final output, but the connection here is linear. They're linear. Okay, all the relationship are linear function. 它是线性的。Okay, this is the first thing you need to keep in mind. All the connections are linear, which what? It is nothing but just a matrix multiplication. Okay, we determine the weight. This is a weight matrix. This is the input matrix. Okay, P means transpose. Then we plus a bias. Okay, a bias. So everything here, this equation show you here is a linear equation. Okay, it's a linear equation. So the connection between 2 consecutive layers is nothing but a linear function. But for this case here, we do some linear combination of the input and the weight. After that, we go for an activation function. Here we have 2 purposes for this activation function. First, an activation function can be nonlinear. Okay, it's nonlinear. Usually it can be nonlinear. So we can convert the linear into nonlinear. Secondly, the purpose for the activation function is because after when we do the weighted sum, the output can be infinite. Okay, it's unbounded. The value is unbounded. But if we go through an activation function, usually the value will be bounded between 0 and 1 or minus 1 and 1. That's the typical case to limit the value, the output value between 0 and 1 or minus 1 and 1. Nothing else. That's the basic idea. And then finally, we output the result. Okay, so here's the activation function. Somehow you can think of activation function could be a way to remove the noise, okay, or something not important. Okay, so that's it. That's the basic concept about neural network. So the most simple way to do to represent the neural network is so-called MLP. Okay, we call it MLP. Means a multi-layer perceptron. Okay, multi-layer perceptron. MLP. Okay. Here's a very simple so-called shallow neural network. For this case here, we have the input layer and we have the output layer. In the middle, this is so-called hidden layer. But take a look. For the connection between the input and hidden layer are linear combination. And also the connection between the hidden layer and the output is another linear combination. Okay, this is shallow. But if we go for a very deep MLP, okay, a deep means I cannot define what is deep. Is too deep enough or not? But usually we expect more than 3, okay, or more, even 10 or more. Okay, so when we talk about a deep neural network, usually you will include, for this case here, you have a hidden layer 1, hidden layer 2, and the hidden layer 3. But again, all the connection between 2 layers is linear. Okay, they can simply calculate by some matrix operation. Whenever we talk about the matrix operation, we talk about the linear function. 我们谈的是线性的 ，OK， 两个之间。But when you go through a lot of linear, which means what? You can use a lot of linear function to represent nonlinear behavior. 也就是说，我们用很多的线性去代表非线性的行为 ，OK。And also, when the output is based on the activation function, activation function is another nonlinear function, okay. But anyway, we use linear, okay, and we use many linear, which means if the layer goes very deep, then you can use a lot of linear function to represent a very complicated nonlinear function. But if you go just one hidden layer, maybe you can just represent a very simple nonlinear boundary. That's it. Okay, that's the idea. So it depends on your application. If your input data is quite simple or linearly separable, then you can simply just use a shallow neural network. But if your data are very complicated, which cannot be separated with a simple linear function, then you may need a lot of very deep neural network. Okay, but up to now, what we are talking about is the MLP. The input are vector value. Okay, 它们都是向量资料，到目前为止啊。But when we come to the so-called convolutional neural network, okay, you have learned this wording, convolution, a lot since we talk about what? Edge detection, right? And image smoothing, image sharpening, okay? You need to do the convolution with the filter, okay, for each individual. Even when we talk about the Gaussian transform, right? We design a set of filter. Then each filter you need to do the convolution. Okay, go through the whole image, pixel by pixel. So everything is based on convolution. So it's the same here. Okay, so for this case, we input an image. And for the user, you need to determine the window, right? The filter size. And then we go for the convolution, and we do the convolution. Again, just like MLP, you can have a lot of hidden layer, but this we call it convolution layer. You can have a convolution layer 1, convolution layer 2. For this case, we have a 1, 2, 3, 4, 5. We have 5 layers, okay? The purpose for the convolution layer is to extract the features. 这些的所有 convolution 的功能就是为了去截取特征 as I mentioned, because the input is unstructured data. So the purpose for the convolution is nothing but for feature extraction. 它只是要去截取它的特征。But the good thing about it is it doesn't not involve any human operation. All the features are determined automatically based on your objective. Okay, so after we extract the feature, then you are connected to. For this case, you are connected to the flattened layer. The flattened layer is nothing but just something like this. Okay, now because as I say, for the MLP, the input is vector value, right? But after we go through the convolution, you can extract the feature, then we flatten, the so-called flatten to represent the feature from 2-dimensional into 1-dimensional, then you can think of the feature as a 1-dimensional vector value. Then usually we will connect to the so-called fully connected layer, okay? And usually we will go for 2 or 3. We don't use 1 because 1 just represents a linear behavior. So usually at this we will connect to 2 or 3, okay? Fully connected layer. Then we output the result. Okay, so the good thing about CNN, as the so-called is so-called end-to-end. Okay, end-to-end. End means what? The input and the output. So the deep learning model can learn the feature automatically, and then it can, based on the extract feature, it can do the classification automatically. We don't need to separate the step. One to extract the feature, either manually or automatically. And once you have the feature, you need to design another decision function, okay? To identify the input as class 1 or class 2, or in manufacturing, then we can classify it as a normal sample or defect sample, okay? So anyway, so-called end-to-end. You will do the feature extraction and the classification or high-level decision automatically, okay, based on some objective. So basically, the type of deep learning model, it can be a supervised model, okay, supervised learning. When we talk about the supervised learning, which means we have the input, no matter the input is a vector value or image or time series data, we have the corresponding output, okay? You need to assign, for example, if you want to identify a cat or a dog, then you might say cat to be 1 or dog to be 2, for example. You need to assign the level, okay? This so-called supervised, okay? 监督式的学习，你要知道。So when you go for the supervised learning, you need to label or annotate each training sample with its corresponding class, which could be very tedious, okay? And there's the industrial. They hire a lot of operators to do the labeling job. Okay. Supervise. Okay, we will talk about this, and then today we focus on the convolutional neural network, and it can be a recurrent neural network. Okay, especially for time series data or for video. Okay, recurrent. We don't have a time to talk about it, and also it's my personal bias. We can simply just go for the convolution network to replace the recurrent neural network. We don't actually need. I didn't say the recurrent neural network is bad, but the training could be more time consuming compared with the convolutional neural network. Okay, I will explain later on why sometimes we simply just use the convolutional network or any other model to replace the recurrent neural network. Okay, RNN 基本上它是用在做时序的。Okay, for example, for video or for language model. Okay, but it cannot take the advantage of the GPU because it cannot work parallelly. If you go, which means if you have the data, okay, you input a series of 3 image frames, for example. When you want to process the image at time t, you need to process the previous x minus 2, t minus 2, and t minus 1. You have to wait. I mean, you cannot use a GPU to process these 3 input information simultaneously. You have to wait. To do the t minus 1, you need to do for t minus 2 or t minus 3 and all previous image. So you lost the advantage with the parallel computation. Okay, that's something which I'm not, but I didn't say you cannot use it. Okay, anyway, we don't have the time for that. Okay, and I will talk about the encoder decoder. Okay, the model encoder decoder. The purpose. Okay, the purpose of encoder is trying to extract the features, and the decoder is trying to extract of the feature. And decoder is for image application is to generate a new image or any image is expected. Okay, that's the basic model. For example, especially for deep face. Okay, you can change the faces. That's based on, you can input someone's face and convert it into some celebrity. Okay, that's based on, you can base on some features and convert the features into another face. That's the image generator. Okay, then we will talk. We'll talk about some of the model and up-to-date model, such as diffusion. I mentioned that diffusion and mask autoencoder. Okay, we'll talk about this one. And unsupervised, we will also talk about unsupervised learning. When we say unsupervised, which means you only have X, you don't have a 1. Okay, the purpose is for classic. You collect a lot of data, but you don't know what is the group of class that belong to. Okay, the good thing about unsupervised is you don't need to do the labeling manually. Okay, so usually for unsupervised, especially for autoencoder, because the input and the output will be exactly the same. Which means what? Whenever you have an image, you just put this image as the input to to your deep learning model, then use the same X as the expected output. That's it. You don't need to do any label. 不用贴标签. This is the best way to go. The application is for anomaly detection, 做异常侦测, especially when you only have a normal sample. For example, for industrial application, you collect a lot of normal sample, but you don't have any defect sample, or the defect sample is only just a very few. Okay, so reinforcement learning will be another technique. Okay, basically it's for robotics. I didn't say you cannot use for image processing, but most of the case is for navigation, for robotics. So I won't cover anything about reinforcement learning, but in Professor Sun's class, I believe he said something about the reinforcement learning. Okay, another class, another model for image processing that does not rely on convolution is so-called the transformer. Okay, so sometimes you will see the VT, okay, especially for or VIT. That's for V means vision, okay, vision or visual. Okay, for visual transformer, because the transformer, the original purpose is for large language, okay, modeling. Okay, someone has converted to computer vision application. So sometimes you will see the abbreviation for VT or VI. VI means vision transformer. Okay, the approach is totally different, but based on attention. Okay, unless I have a time for that, otherwise I will skip this part. Again, as a personal bias, up to now for my research work, I cannot find its advantage for most of manufacturing application. Okay, but again, don't misunderstand me. Okay, I didn't say it won't work for everything, because it uses a lot. As you say, especially for the large language, as you say, ChatGPT, blah, blah, blah. All the language model is based on transformer, okay? But because the training is relatively more difficult compared with a convolutional neural network, okay? That's one of the reasons, and for some case, I just cannot find its advantage over others. Okay, besides for image, for when you apply the transformer, you need some position encoding. You need to do some position encoding. That's good for language. Okay, I mean position encoding. For example. Because if I say I am a student, you need to encode, okay, so that you will know the relationship between every pair of the word. But when you come to the image, you need to encoding every pixel. It's not natural for me. It's not natural. Okay, but the good thing is that you can find the correlation between, right? Okay, they are so far away from each other. But when we talk about the convolution, because it designed a filter, so even though this filter will go through pixel by pixel, but it can only describe the relative relationship in a small neighborhood. That was some of the limitation about the convolution, but when you go for the transformer, because each pixel you need to define, you need to encode it into some position. But for the real application, I think it's not natural, and it's very difficult to represent that. Okay, it's fine for the language because you need to know. Okay. Something. all the relationship. Okay, I talk too slow. Okay, I need to go fast. Okay, so here's a lot of terminology you need to know for the convolutional neural network. Here you need to know first convolution layer, activation function. I mentioned that it could be nonlinear. It can convert the value between 0 and 1 or -1 and 1. Okay, and later you can do the pooling. I will explain that. Okay, in case you don't know that. Batch normalization, then flatten. Flatten is we extract the feature, then we convert the two-dimensional features into one-dimensional vector. Okay, that's called flatten. 把二维转成一维. Okay, then we go for the dense function or the fully connected function, fully connected layer. Okay, fully connected layer. Actually, the dense function or fully connected layer is used for decision making. Okay, for classification or even for segmentation. Then we might do the dropout. You may drop some of the node. Especially in the fully connected layer. The purpose for dropout is what? To prevent overfitting. Okay? Prevent overfitting. 它避免你训练的过度拟合. Okay? It looks quite weird. Okay? But we will spend that. Okay? And finally, the output layer. Okay? That's the architecture. For the architecture of convolution neural network, you are involved this. Okay, input layer. Let me say one more time. Input layer, convolution layer. Okay, after the convolution, then we will go for the activation function to convert it into a limited range and also make the output nonlinear. Okay, and after that, you may go for the pooling or you don't need the pooling at all. Okay. And then you may decide you want to do the normalization of the convolution or the activation function value. Okay? And then we flatten. That's required, especially for image. If the input is the time series data, then we don't need to do the flatten at all because the input is already one-dimensional. And then we do fully connected. You may decide you want to apply dropout or not. And then, of course, definitely in the output layer, okay? No matter it's for classification or for segmentation in image. Okay, that's the basic sum of the function. Okay, so first, the success of a good deep learning or convolutional neural network model, well, based on the following three, okay? Requirement. First, you need to have a good training data set. Okay, you need a good training data set. You have to make sure the training data set are sufficient. And if for supervised label, you need to make sure each data point is labeled correctly. You might say it's not a problem, but actually it is a problem. Okay, especially you hire some of the operator to do the annotation. Maybe you need to make sure the quality of level is correct. Okay, otherwise it could be just garbage in, garbage out. Okay, so it's very important. You have a good training sample. You have enough good training sample, and also for classification, you have to make sure all the sample point for a specific class are sufficient. You might hear a lot of people talk about the neural network have a bias. One of the sources for the bias is from your training data. Because suppose you have a two group, okay? A group could be male, B group could be female, for example. But if you have a 1 million sample, for this one, you have only 100 So when you train your model with 1 million male samples, but with only 100 female samples, what can you conclude? Whenever you have a new sample to your model, you will say everything will be male or related to male. You know what I'm saying? Because you have only 100 female subjects. However, you have a 1 million. So if I say everything is male, what is the error rate? If I say everything will be male, this is your error rate. No better model can do this thing, can have the accuracy like this. This is the so-called data imbalance or imbalanced data, imbalanced 不平衡的质量. This is one of the source for bias. Okay, so if I have time, I will talk about how to handle it. That's another reason why we need to go for anomaly detection. We just train one single class. Okay, we just train something A. All the sample from the male subject. And then everything outside the boundary, then it will be, it may not be B, but at least I know it's non-A. That's it. That's the purpose for anomaly detection, especially you have the imbalanced data. Okay, we just train one single class, and anything else will be non-A. Okay. The other source you might fail is you don't have a good model of structure. Like this one, you need to determine how many layers, how many convolution layers you need, and how many filters you need to extract the features. Just remember we talked about the Gabo transform. You have 4 scale and 8 direction, but you need to add just 4 scale or 8 direction will be sufficient or not, right? Then there's a lot of questions you need to determine, okay? Especially the number of filter and the filter size in each layer and how many layers you need, okay, for your application. And lastly, as I mentioned, all the filter can be determined automatically, but based on your objective. So first, you need to set up a good objective. It's called loss function. And then once you have the objective, once you have the decision variable, then all the remaining thing that the system need to do is about optimization. What should be the optimization? How to learn it, or how to train the model, so you can find the best parameter that will return the optimal loss function. That's it. Okay, so all these 3, when you train your model, you need to determine, do I have a good training data set? Is the structure or the architecture of the model is good enough for your application? And then what should be the optimization? Okay, so we'll talk about these 3, especially this one, okay, this one, okay, and also we'll talk about optimization. Okay, so I will skip some of the details. But anyway, just think of it. If I have an image which is a 1K by 1K, okay, 1K is 1,000. If I use the node, okay, 1K by 1K is how many pixels? 1 million. 1 million. So you have 1, 2, and up to 1 million input. Now, just think of it. If I have a 1 million, and the hidden layer is okay, I just make it up. I have a 10 node, okay? Node 1, node 2, just 10. And each one, you need to do the fully connected. Then how many parameters? Each one will be the parameter. How many parameters you need to determine? That will be 1 million times 10. That will be 10 million. Then you have a 10 million decision variable. 就这样走，这才开始，什么都还没做。But if we go for the CNN, think of it. If this input is 1K by 1K, and the convolution layer, if I go for 1, I just use 1 3x3 filter. Then how many parameters? A 3x3 is nothing but you only have a 9 parameters, and you need to do the convolution for this 3x3 filter throughout the whole image, pixel by pixel, but with the same filter. That's the idea. It's so-called here. It says here, the CNN are parameter sharing. They share the same filter. And hopefully this filter can help you to extract the features. Okay, some of the main features based on this filter. And make it simple. If you have the filter like this, and you have another filter, goes like this. Then this filter, you need to do the convolution throughout the whole image. So this will extract what kinds of feature. What? Vertical, just vertical line of the object. This filter will extract the vertical line. You know what I'm saying? Okay, that's the idea. Okay. But just for one filter, the parameter is only 9 compared with this one that then it needs 10 million of the parameter. Okay, so the convolution, especially for the unstructured data, when I say unstructured, I mean the image, okay, and time series. They are not vector value, but it extracts a feature based on the filter. But the filter is not manually given, it is determined automatically. Okay, I didn't say you will have the filter like this. No, I just give this example. For example, you have the filter like this, and then you will extract the vertical line in the image, and this one you will extract the horizontal line. That's it. Okay, so that's so-called is parameter sharing. So you can reduce the number of decision variable significantly. Okay, and you leave the work to your CNN model. That's it. Okay, you don't need to worry about what should be. Okay, let me just repeat it one more time. Okay, the convolution, as we talk about the edge detection, we only know everything this, right? We just do the, convolution if the input is vector, then you have learned it since the high school. It's called inner product. 就是内积，哈，不要 convolution 还是什么东西，就是内积，它跟内积一模一样，你把它当向量。But inner product is for one dimension, okay, vector. Convolution is for 2 dimension. That's it, okay. If you use a Keras or Google's the mathematical tool, it's called tension, right? It's tension. 它就是 tension, okay? So you have learned this. Okay, I just give this example. Okay, I just give this example. So first, for edge detection, you can have the filter is 3 by 3 or 5 by 5. So first you need to determine that. You need to determine this manually. What I'm saying could be wrong because there's some tool called auto ML. You will determine what should be the best filter size for your application automatically. But basically, you need to determine your own filter size. Okay. The good thing about all the element will be determined automatically. Okay. So you have learned this. Okay. If I extract horizontal or vertical features. So just give you the idea. Okay. Anyway, after the convolution, this is the so-called feature map. You can think of this. If I do the convolution of the original image, okay, pixel by pixel, by sliding the window pixel by pixel, and then you can extract this as a feature map 1. If I go do the convolution with this filter, okay, again, slide the filter pixel by pixel in the original input, then you can have another feature map. This is so-called the feature map, okay? So if the input is two-dimensional, usually I should say usually, the output of the feature map is also two-dimensional, okay? But the depth could be changed a lot, okay? For this case here, the depth is only 1. But if the input is a color image, then the depth will be 3. Okay, you must be very careful when you read the paper or the textbook. When you see the word depth in deep learning, depth could mean the number of convolution layers. Okay. 就是你的网络要多深 But when we talk about the input data, then the depth means the number of channels. Number of channels. So for a color image, the original input has 3 channels that contains R, G, and B. Okay. 好，所以我们在谈那个深啊。你要看是 when we talk about the model, we mean the number of convolution layer. Okay, I'm going too slow. Okay, but anyway, okay. So anyway, just give me 1 more minute. Okay, suppose we have the input like this. Okay, 32 by 32. Okay, suppose we have an image like this, and the depth is 3. That's why here, because we are talking about the input. Okay. 3, that's because we have R, G, and B. Okay. Now, the filter must be also have the same depth as the input. If the input is 3, then the depth of your filter must be also 3. If the depth is 5, then the filter must be also of depth 5. Okay, let me say that one more time. The depth of your filter must be the same as the number of channels for the input. They must be exactly the same. Cannot be less, cannot be more. They must be the same. And if you have a depth 3, here's how we do the convolution, okay? This is for grade level image, then we just do the convolution, okay? It's simple. But if the filter, as I mentioned here, I put FC. C means R, G, or B, okay? You have a 3 channel. Then we do the convolution for each channel. For each individual channel, KWC means we have the filter for R and G and B. And then we assume the same as the previous one. We do the convolution, but finally we sum that up. Okay? That's so-called the convolution if the depth is more than 1. 也就是说这边的 convolution 呢，这边的 convolution 一模一样，只是呢你要个别的 channel 要个别做完以后再加，再把它加起来。So the output is a scalar. It's a single value. The output, okay, at a very specific location x, y. After you do for this case, after we do the convolution with the RGMB, the output is a single value. It's not a vector. Okay, it's a single value. 不要把它想歪了哈。The output is not 3. We don't have a 3 value. No, one single value. Okay, so that's it. Take a break.